let's get into solving some of the questions from the topic number systems. So let's go into the first question. The unit place digit in 9 raised to 201. So we have 9 raised to 201. This seems like a very huge number, and we have to find what is in the unit place of that number. So is there any way to find it? Because we know that 9 square is 9 into 9, 9 raised to 1 is 9, 9 raised to 3 is 9 into 9 into 9, and so on. So 9 raised to 201 means that we have to multiply 9 for 201 times. So is that practically possible to us right now without using a calculator? So let's see how to find a digit which is in the unit place of 9 raised to 201. So first of all, we'll go and see the pattern of how this is going. 9 raised to 1 is 9. 9 raised to 2 is 81. 9 raised to 3 is 81 into 9. 72 it is. So it's 729. 9 raised to 4 is 9 into 9 into 9 into 9. So that is 729 into 9, which is 81. So 9 to the 18. 18 plus 8 is 26. 9 sevens are 63 and 65. We get this as 6561. So here we could find that it's very interesting to see that the digits in the unit place just keeps on repeating. Here it's 9, it's 1, and then again it's 9, again it's 1. So it is repeating in an interval of 2. So we could say that 9 raised to 2n, if we are doing 9 raised to 2n, that is, if we are saying 9 raised to 2, we are getting 81. If we are saying 9 raised to 4, we are getting 6561. In both of these numbers, we find that in one's place, it's 1. So we could see whether 201 is a multiple of 2. So is 201 a multiple of 2? It's not. So which is the closest number which is a multiple of 2? It is 200. So we could say that for 200, 200 can be written as what? 2 into 100, which is 2 into n. For this one, the last digit would be 1. And for the other number, it would be 9. So 9 is the right answer here. So let's move on to the next question. The smallest number which, when added to the greatest 4-digit number, which makes the sum divisible by 345. This question seems a little bit tricky, but let's see what it is. The smallest number, so there is a number, say, I'm naming that number x, which when added to the greatest 4-digit number, what is the greatest 4-digit number? It's 9999, which makes the sum divisible. So we are saying that x plus 9999 could be completely divided by 345. So what is very interesting about this? The number 345. Why is it? Because 345 is divisible by 5. So if a number is divisible by 345, it also means that it should be divisible by 5. So what are we going to do? We have 9999, and what is the property for a number to be it divisible by 5? The last digit should be 5 or multiples of 5. So how would we make the last digit 5 or a multiple of 5? We could add 1, but is that in the option? No, we don't. So what happens if we add 5 to it? When we are adding 5 to it, 9 plus 5 is 14. So this becomes some number, but the final digit is 4, which is not a multiple of 5. And we need a multiple of 5 to be in this place. So we try adding 6 to it. When we add 6 to this, we get 9 plus 6, it's 15. 9 plus 1 is 10. Again, 9 plus 1 is 10. 9 plus 1 is 10. 10,005, which is divisible by, which is a factor of 345. And that's how we identify the number, which is 6. It is the smallest number when we add to the greatest 4-digit number, which makes the sum divisible by 345. The question is actually framed in a tricky way in this, but still it's a very easy concept. You don't have to worry by seeing the number like 345 because you don't know the divisibility by 345. You find the smallest number you know the divisibility of, which is 5, and then you just find the number. So let's move on to the third question. Third question is actually a very simple question which is using the BODMAS rule. So what was BODMAS rule? Brackets, order, division, multiplication, addition, and subtraction. This is the order in which we'll do this question. So what is inside the bracket first? 6 plus 3. 6 plus 3 is 9 into, what is 9 inverse? We were talking about reciprocal of numbers. We know that 9 inverse is 1 by 9 because we're solving orders next. Divided by 2 inverse square. Here it is actually given 2 raised to minus 2. It's very simple what it means. It means 1 by 4. So this is 1 by 4. Because 2 square is 4. But if 2 is raised to 2 times in a negative way, it means that it's 1 by 4. So we reached from here till the point 9 into 1 by 9 divided by 1 by 4. So which operation, multiplication or division, should we do next? We have division before multiplication. So from here, we do the division first. How do we do that? We keep the 9 here without disturbing this. Now we go here and it's 1 by 9 divided by 1 by 4, which again comes out as 9 into 1 by 9 into reciprocal of 1 by 4 is 4 by 1. So here now it's completely turned to 9 into 4 by 9, which is equal to 4. Now we got the answer as 4, but is there 4 in the option? Yes, it is. Here an option is given as 16 divided by 4. What is 16 divided by 4? This is 4. So the options is actually made in a way that it's a little bit tricky to understand whether there is 4 because 4 is a whole number and it's given in fractions. So we should keep in mind that the answer could also be given in this way. So let's move on to the next question. The next question gives 25450. It should be expressed in standard forms. So what or how should we express it in standard form? First of all, the standard form should be a form where a into 10 raised to k, where a should be lesser than 10 and greater than 1. There should be an equal to here. Okay. So, which is the number which is in between 1 and 10, which includes 1 and 10? 2. We choose 2.5450. Now, how many decimal places did we move on to now? We moved on to 4 decimal places, so we'll put 10 raised to 4 here. And we got the answer D. Moving on to the next question. Out of the following rational numbers, which is the smallest? So firstly, when you're looking into the options of these questions, we got 4 options here. 2 of them are negative numbers and 2 of them are positive numbers. So which is the smallest one? Of course, it's the negative numbers, so we could eliminate the chance of these 2 options being the right answer. Now we have 2 numbers with us, which is minus 5 by 7 and 4 by minus 7. The thing is, 4 by minus 7 is actually equal to minus 4 by 7. You could place the negative sign anywhere. So let's compare minus 5 by 7 and minus 4 by 7. Minus 5 or minus 4, which is the greater number? The greater number is obviously minus 4 and the smaller number is minus 5. Why? Because of the minus sign. So now we get that minus 5 by 7 is lesser than minus 4 by 7. So this is the right answer. Now, moving on to the next question. Which of the following is a prime number? So, how do we check whether a number is prime? We check the number of factors in there. So, 15 have a factor of 1, 3 and 5. 29 have a factor of 1 and 29. 36 have a factor of 1, 3, 6 and 36. And 51 have a factor of 1, 3 and 51. Now how do we know this? First of all, 5 plus 1 is 6. So it is divisible by 3. Now we know that 51 have more than 2 factors. And 36 have 4 factors and 15 have 3 factors. So 21 have only 2 factors, which makes it a prime number. Now, next question. The property of a rational number that states for any rational number a by b, where a and b are integers and b not equal to 0, there exists a unique integers p and q such that a by b equal to p by q and q not equal to 0 is known as. So what is this property stating? For any rational number a by b, where a and b are integers and b is not equal to 0. B is not equal to 0. So a by b is a number. There exist unique integers p by q, p and q such that a by b equals p by q, where q is not equal to 0. Which property is this? What is closure property? Closure property says that if a and b are one type of rational number, then a plus b, a minus b, a divided by b and a minus b is also a rational number. What is commutative property? Commutative property says that if a plus b, a and b are two numbers, a plus b is equal to b plus a. And what is rationalization property? Rationalization property is exactly stating this. So it is the answer for this question. Now, next question is, which of the following rational numbers lies between minus 5 by 6 and minus 1 by 2? So we have to compare two rational numbers and their denominators are different. So what are we going to do here? We have different methods of solving this problem. But here, I am going to make the denominators same for the question. So we have minus 5 by 6 and minus 1 by 2. So what is the common factor in these two? We could make it as 12. So I'm saying minus 5 by 6 into 2, multiplying the numerator and the denominator, and we get minus 10 by 12. Same thing I'm doing to minus 1 by 2. I have to change the denominator into 12, so I'm multiplying it by 6. And at the same time, I'm multiplying the numerator with this and I get minus 6 by 12. So what number lies between minus 6 by 12 and minus 10 by 12? We could say minus 9 by 12, minus 8 by 12, minus 7 by 12. Do we have any of this in the option? Yes, we do. And this is the right answer. Now we have another question. What is the value of 3 plus root 5 the whole square minus 3 minus root 5 the whole square? So we all know the formula of a plus b the whole square. A plus b the whole square equals a square plus 2ab plus b square. And a minus b the whole square equals a square minus 2ab plus b square. So let's solve this with these equations. We have a equal to 3 and b equal to root 5 in the case first. And we have a equal to 3 and b equal to minus root 5 in the second place. So what is 3 plus root 5 the whole square? It's 3 square plus 2 into 3 into root 5 plus root 5 the whole square. And this would be equal to 9 plus 6 root 5 plus root 5 into root 5 becomes 5. How does this happen? Because we know that what is root and what is square root. 5 square is 25. This is 5 into 5. So we could say that root of 25 equals 5. The same thing we are doing here, and we get that root 5 into root 5 gives us 5. So this is 5. And 9 plus 5 is 14 plus 6 root 5. And let's move on to the next one, which is 3 minus root 5 the whole square. What is 3 minus root 5 the whole square? 3 square minus 2 into 3 into root 5 plus root 5 the whole square. So 3 square is 9 minus 6 root 5 plus 5. We get 14 minus 6 root 5. Now we know the value of both of these. So let's substitute it in here. Here we got 14 plus 6 root 5 minus, we are putting a bracket here, 14 minus 6 root 5. So doing the calculations, we have to multiply the negative sign inside the bracket. So 14 plus 6 root 5 minus 14 minus into minus gives us plus, which is 6 root 5. Cancelling out both of these, and we get 2 times 6 root 5, which is 12 root 5. And here we got the answer. So let's move on to the next question. Which of the following is not a rational number? So what are rational numbers? Rational numbers are the numbers which can be expressed in p by q form, or which can be expressed as a fraction. So here the one condition we have is q should not be equal to 0. So can 0.45 be expressed as a fraction? Yes, it can be, because we are converting the decimal. We could write it as 45 by 100. Can we write 0.3333 as a fraction? Yes, we can. We can write it as 1 by 3. Can we write root 3 as a fraction? No, we can't. So this is our number which is not a rational number. So next question is, what is the remainder when 693 is divided by 7? So this is a tricky question maybe, or is it? Let's see whether 693 is divisible by 7 first of all. What was the rule for divisibility of 7? So if we have a number say 693. We take the number in the unit place, we multiply it by 2, we get 6, and we subtract it from the rest of the number, which is 3 and 6. Is this divisible in 7? Yes, it is, because 9 into 7 equals 63. So the remainder here is 0. Moving on to the next question, which of the following numbers is divisible by 9? So what is the property to be divisible by 9? If you add the digits of the number, you should get a digit which is 9 or is a multiple of 9. So if you're taking 3051, what is the sum of the digits? It's 8 plus 1, it's 9. And I think we got the answer here, but still we'll check all the other answers, which is 3864. 6 plus 4 is 10, 10 plus 8 is 18, and 21. 21 is not divisible in 9. 4029. So 4 plus 2 6, and 6 plus 9 is 15. 15 is not also divisible in 9. Now we are checking 5112. So 7, 8, 9. 3 plus 4, 9. This is also giving us 9. So this question might have two answers, which are these both. Now let's move on to the next question. Evaluate 3 plus 4 into 2 minus 6 divided by 3 plus 1. So how do we do this? Again, let's go with the BODMAS rule. So first we do the brackets. So first, what do we have inside the bracket? In the first bracket, we have 3 plus 4 into 2. And what do we do first? Multiplication or addition. We do the multiplication first, so we get 3 plus 8, which is 11. So for this, we get 11 as the answer. And let's see the other bracket. 6 divided by 3 plus 1. So division first and then addition. 6 divided by 3 is 2 plus 1 gives us 3. So for the final answer, it's 11 minus 3, which gives us 8. Moving on to the next question. Express 45000000 in standard form. So what do? How do we express a number in the standard form? It's a into 10 raised to k, where 1 less than or equal to a less than or equal to 10. So which is the number which stays like that? It's 4.5, and we have 1, 2, 3, 4, 5, 6 zeros here. So we moved 7 decimal places. So we know that 4.5 into 10 raised to 7 is the right answer. Now, which of the following is a prime factorization of 96? How do we do the prime factorization? We take 96. Let's do it with 2. It's divisible by 2. So 4 2s are 8. 1 remainder here. So 16. 8 2s are 16. Now again by 2 we get 24, again by 2 we get 12, again by 2 we get 6, again by 2 we get 3, we do it by 3 and we get 1. So this turns out to be 2 into 2 into 2 into 2 into 2, that is 5, 2 into 3. So 2 raised to 2 into 2 raised to 3 into 3. This is the right answer. Moving on, the least number that should be added to 1923 so that the resulting number is exactly divisible by 9. It is a very simple question because 1923, what is the sum of the digits? 9 plus 1 is 10, 10 plus 2 is 12, 12 plus 3 is 15. So what number should be added to 15 for it to become a multiple of 9? What is the multiple of 9 which is very closer to 15? it's 18. So if we add 3 to 15, we get a number which is divisible by 9. So the answer is 3. The next question is, which of the following numbers is not divisible by 6? So, what is the divisibility criteria for a number to be divisible by 6? The number should be divisible in both 2 and 3. So, 2730, it's obviously divisible in 2 because it's an even number. Now let's check with 3. 7 plus 3 is 10 and 10 plus 2 is 12 and 12 is divisible by 3. So this is divisible by 6. Now 3504. 5 plus 4 is 9 and 9 plus 3 is 12. So it's divisible by both 3, and as it's an even number, it's divisible by 2. Now 4320. 4 plus 3 is 7 and 7 plus 2 is 9. 9 is divisible by 3, and as it is an even number, it's divisible by 2. Now let's check the last one, 5102. 5 plus 1 is 6 and 6 plus 2 is 8, which is not divisible by 3, but it's only divisible by 2. So this is the answer for this question. Now moving on to the next slide. Simplify the expression 5 into 3 minus 2 the whole square plus 4. Again, we are using the BODMAS rule. So first we'll find the answer of the bracket. So it's 5 into 1 square plus 4. Now we have to do the multiplication. 5 into 1 is 5 plus 4, which gives us 9. This was a very easy question to solve. Now moving on to the next question. If a equal to 3, b equal to minus 2 and c equal to 5, evaluate the expression 3ab plus a minus b into c. So we don't have to do anything other than BODMAS rule again here. Just substitute the value of 3 into a is 3, b is minus 2, plus a minus b means 3 minus minus 2 into 5. So what do we do first? We do the brackets here. These are not brackets, these are just multiplication. I'll rewrite it again. So we'll not put the brackets here. We'll just do the multiplication. So it's 3 into minus 2 in plus 3 minus minus 2 into 5. So what is inside the bracket here? It's 3 into minus 2 plus 3 minus minus 2 means 3 plus 2, which is 5 into 5. Now we'll do the multiplication. What is the multiplication part here? 3 into 3 is 9, 9 into minus 2 is minus 18, and 5 into 5 is 25. Now when we add both of these, let's see what we get. It's 25 minus 18. So this becomes 15, this becomes 1. We get 7 here. Which of the following is the largest prime number? So this question asks us about the largest prime number. We'll check what the prime number things are. So the prime number shouldn't be a divisible of 3 or 2. So 999 straight up is divisible by 3. So this is not a prime number. This is not a prime number, yeah. And 1029, 2 plus 1 is 3 and 3 plus 9 is 12. It's again a multiple of 3. So this even can't be a prime number. Now we have both of these, and we know that 19 is a prime number and it's bigger than 1009. So this could be our answer. Now the next question, express 0.00000000 to 7 in standard form. So again, how many zeros are we shifting here? We are shifting the first 0, second, third, fourth, 5, 6, 7, 8, so that we'll get the form 2.7 into 10 raised to minus 8, which gives us the answer here. So, moving on to the next question. We have the question, what is the value of 0.5 whole raised to 3 plus 0.5 whole raised to 4? For this, we need to find the value of 0.5 cube and 0.5 raised to 4. We know that 0.5 raised to 2 is 5 into 5 is 25, and we put 2 decimal places, that is 0.25. Now we have 0.5 cube, which is 25 into 5 is 25 into 5. So 5 5s are 25, 5 2s are 10 and 12. It's 125. So we have 125 and we have 3 decimal places here. We put the 3 decimal places and we then move on. 0.5 whole raised to 4 is 0.0625. How do we know that? It's 125 into 5 is 625, and we need to put 4 decimal places in order to balance this. So now we have to find the sum of this, which is 0.125 and 0.0625, which is 5781.0. The closest value we have here is 0.25, so we're marking this as the answer. Now let's move on to the next question, which is, what is, if a and b are integers where a is greater than b, which of the following is true? So we have 4 options here, which is a plus b is greater than a minus b, a plus b is less than a minus b, and a plus b is equal to a minus b. We could really say the answer is a plus b is greater than a minus b. Now moving on to the next question. What is the unit digit of 3 raised to 45? So let's see the pattern of 3 raised to 45, because 3 raised to 45 is a really huge number. So let's see. 3 raised to 1 is 3. 3 raised to 2 is 9. 3 raised to 3 is 9 into 3, which is 27. 3 raised to 4 is 27 into 3, which gives us 71. 3 raised to 5 is 71 into 3, that is 213, and 3 raised to 6 is 213 into 3, which is 936, 639. We see a pattern in the ones place again, which is 3971. Again it goes like 3, 9, 7 and 1. So at what rate is it changing? So first it was 3, and then it again became 3 in the ones place after 4 digits. So we could say that if we are saying 3 raised to 4n, we will have 3 at the ones place. So let's see whether 45 is a factor of 4. It's not a factor of 4. So which is the closest number which is near to 45, which is a factor of 4? It's definitely 44. So for 44, 3 is in the ones place, that is in 3 raised to 44, we have 3 in the ones place. So what would be it for 3 raised to 45? It would be 9. And thus the question is solved. Now we are moving on to the next question. If a number is divisible by both 3 and 4, then it is also divisible by, it's a very simple and very straightforward question. It's 3 into 4, which is 12. Now let's move on to the next question. What is the value of 2 minus root 3 into 2 plus root 3? Now we know this formula where a plus b into a minus b equals a square minus b square. So we have 2 plus root 3 into 2 minus root 3, which would be equal to 2 square minus root 3 square. So this is 4 minus 3, which is equal to 1. We got the answer here. Now, which of the following is the largest rational number? So we have 4 different numbers with different numerators, which is also negative. Let's see. We could write negative 1 as negative 1 by 1. We have minus 2 by 3. We have minus 3 by 4. And then we have minus 4 by 5. So what do? We could actually change the denominator of every number. So what should we change it to? We need a common factor for 3, 4 and 5. So we could say 3 into 4 into 5, which means 20 into 3, which is 60. Either we could do this. Let's try doing that. So how to convert this 1 to 60? We multiply it by 60, both numerator and the denominator. Next fraction. How to convert minus 2 by 3? The denominator have to be 60. So we need to multiply it by 20. So minus 2 into 20 is minus 40 divided by 60. So the next one, minus 3 by 4. So how much of 4 is 60? 15 times 4. Let's see. 5 was 20. Yes. So we multiply both of these with 15. 15 into 3. So we have minus 45 divided by 60. And again, how many times 5 is 60? 12 times 5 is 60. We could say 12 into 5. 5 2s are 10, 5 1s are 5 and 6. So we could multiply this by 12 and 12. Minus 4 into 12 is minus 48 by 60. Now we are talking about negative numbers and we have to find the largest rational number. So among this, which seems to you the largest? Because the smallest number, the digit, would give us the largest number, because obviously we know that minus 500 is less than minus 1. So which is the largest here? Minus 40 by 60 is the largest number, which means minus 2 by 3. Let's move on to the next question. Again, it's a board mass question. We have 6 plus 12 divided by 3 into 2 minus 8. We are following board mass. So first goes the brackets. There are no brackets. There's no orders. First we do the division. So what is 12 divided by 3? So it's 6 plus 4 into 2 minus 8. Now comes the multiplication. That's 6 plus 8 minus 8. So plus 8 and minus 8 get cancelled and the answer is 6. We actually have a mistake in the options here. The actual answer for this question is 6. It's given 16, but the answer is 6. Now, moving on to the next question. What is the remainder when 2 raised to 30 is divided by 5? So, what would be 2 raised to 30 be? So, this is a tricky question, a little bit tricky. Let's see. So, let's find the number which is in the ones place for 2 raised to 30. We know that 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 8 into 2, 16, 2 raised to 5 is 16 into 2, 32, and 2 raised to 6 is 32 into 2, 64. So, 2, 4, 8, 6. Again, it would repeat 2, 4, 8 and 6. So, it's repeating in a factor of 4. So again, 2 raised to 4 times n would yield a number whose ones place have 2 in it. So is 30 a multiple? Is 30 a multiple of 4? No, it's not. So what is the number which is very close to 30 and is a multiple of 4? We could say that it's 28. So 2 raised to 28 would end in a number with ones place 2. So 2 raised to 29 would have a number whose ones place would contain 4. And 2 raised to 30 would have a number whose ones place would have 8. So it's easy that if I subtract 5 from 8, we get 3, and 3 is the answer here. Now, let's move on to the last question. What is the sum of all positive factors of 20? So let's write down the factors of 20. We have 1, we have 1 into 20, we have 2 into 10. What else do we have? 4 into 5 and 20 into 1. So let's add all these numbers. We have 1, 2, 4, 5, 10 and 20. So 1 plus 2, 3 plus 4, 7. 7 plus 5 is 12. 12 plus 10 is 22. And 22 plus 20 is 42. So we have solved 30 questions right now for number systems.